All right, in chapter 12, we are going to start getting into organic chemistry. And specifically, this chapter is going to be about hydrocarbons. All right. The class of compound or the family name of these particular hydrocarbons are called alkanes. All right. Notice they end in ANES. We're going to talk about other class of hydrocarbons called alkenes and alkynes and aromatic compounds, and they are all types of hydrocarbons. Basically, a hydrocarbon is any molecule that has only carbons and hydrogens on it. There are no other heteroatoms. There's no oxygens, nitrogens, or halogens, or anything like that. But this particular chapter is about alkanes. And alkanes are when all of your carbons in your molecule have single bonds. You don't have a double bond because these compounds exist, a molecule with a double bond, with triple bonds, and also what's called aromatic compounds, which we'll talk about in a later chapter. But this whole chapter is all about just alkanes, all the different types of alkanes. We're going to learn about some of their properties and learn how to name them as well. All right, so if you look on the bottom, they kind of show you one example of one. But basically, alkanes contain chains of carbons, but no rings. All right, so they're considered acyclic, meaning not cyclical. We will talk about hydrocarbons that are rings in this chapter. And they have a general formula of CnH2n plus 2. So for example, if I have a molecule that let's say has 10 carbons on it, I can figure out how many hydrogens that acyclical alkane is going to have. It's going to have 22 hydrogens on it. You just plug in 10 for there. 2 times 10 is 20, plus 2 is 22. So that's kind of a neat little formula. If you're given a compound, 8 carbons, and it tells you it's an acyclical alkane, you can pretty much figure out that it would have 18 hydrogens. Okay. Cyclical alkanes are what's called saturated. You've heard this term saturated and unsaturated, specifically with fats and oils. And all that term means is that it has the maximum number of hydrogens on your molecule. Okay, because if I have a double bond, let's say I have a CC double bond, all right, remember carbon can make 4 bonds, all right, let's say I have hydrogens here, okay. What we can do is a process or a reaction called hydrogenation, which is where you add hydrogen to the double bond. Double bonds are very reactive and they react with a lot of compounds, specifically hydrogen, to actually put 2 more hydrogen atoms on your molecule. So I can put more hydrogen atoms on the molecule if I have a double or even a triple bond. Once I have a single bond, I can't add any more hydrogens. That's it. Once you have an alkane, you are done with. You can't really do many reactions. There's 2 reactions or 2 things that we're going to talk about this chapter that you can do with alkanes. But really they are not very versatile compounds. So if you have all single bonds, you have the maximum number of hydrogens on your molecule. All right, and here's an example. I think this is 11. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so this is C11, H, most likely that should be 20, 11, 22, 24. C11, 24. So here's just an example. Very long chain, all saturated, no double, triple bonds, all single bonds. Okay. And you can also have cyclical alkanes. Like I said, this is cyclohexane. This is one of the most common cyclical alkanes. Here they're kind of showing it to you in what's called a chair conformation. We're really not going to talk too much about it in this class, but basically it does not exist as a flat molecule. It actually exists in this 3-dimensional structure. It's kind of hard to see the chair conformation of it. If you look at it sideways, you can see it. Maybe if we have time in class, I can kind of show you the chair conformation, but it's not something that you are responsible for knowing. All right, so cycloalkanes have the general structure CnH2n. So notice the +2 is missing. The reason is because as soon as you bind a molecule, you lose 2 hydrogens. Like here, I'll show you. Let's say we have CH3, CH2, CH2, CH2. I'm sorry, CH3. Whoa, that's a weird looking 3. CH3. Okay, so I got 4 carbons. All right, So this would, if this is acyclical, so C4H10. All right, if I were to close this up, let's say I wanted to bond this carbon to this carbon. Well, if I want to do that, I have to get rid of one of these hydrogens, and I have to get rid of one of these hydrogens. Because remember, carbon can only make 4 bonds. If I just make a bond with carbon, then carbon is making 5 bonds. So I have to get rid of one hydrogen here and one hydrogen here. So I would have a CH2, 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 bonded to a CH2. So that would be a cyclical alkane. This is called cyclobutane because it's 4 carbons. We'll talk about how to name a certain amount of carbons, bute, meth, hex. And notice they're all CH2, so I had to get rid of 2 hydrogens. That's why this formula doesn't have a +2 anymore. So if you have a formula where it's a CnH2n and you know it's an alkane, it's got to be a cyclical alkane. If you have a formula that's a CN8 and a H2n +2, then you know it's a straight chain. All right. All alkanes have the suffix of ane. That's how you know the name of the molecule. All right. So we're going to talk a lot about naming this chapter, but just to kind of give you a heads up, this is a cyclical compound, so it's cyclo. Hex is the prefix for 6 carbons. And then since it's all single bonds, the family of compounds is the alkane, so then it's an ane. So this 3 pieces of information tell me I have 6 carbons, all single bond to carbon, and it's in a cyclical structure. So that would be the structure. Okay, so we're going to kind of go through the first 5 carbons, and kind of talk about properties and structures. We're actually going to go through 1 through 10 of carbons. Okay, but the first 5 we kind of go into more information, and they all are true with the rest of the 10. Okay, so the first one, the most simple organic molecule, which has 1 carbon and 4 hydrogens, is called methane. Okay, it's a 1 carbon. It's in a tetrahedral shape. All right, you can kind of see the 3-dimensional shape here. All right, this wedge means the hydrogen is coming out towards you. They kind of show you what's called a ball and stick model. And this hydrogen with the dotted lines is the hydrogen is going into the back. So that's what that is. And then these are in the plane. All right, so this is a 3D representation of it. We're going to talk a lot about 3-dimensional structures in a different chapter. So this is the structure of methane. Okay, meth is the prefix for a 1 carbon molecule. If you got a molecule as 1 carbon, it doesn't matter if I have an OH here or a Cl or BRs or nitrogens or a double bond to oxygen. It doesn't matter. If it's 1 carbon, the name of it is going to have meth as the prefix, and then the ending of it will change depending on what type of group I have on it. Okay, so in this case they're alkanes, so there you go. All right, the second type is called ethane. All right, this is with 2 carbons, so a 2 carbon chain is called eth, and then since this is a hydrocarbon, it's ane, and it's a CH3. You see 2 carbon-carbon bonds. They kind of have this zigzag look to it, all right, because we're going to see in a different slide, but you want all of these groups to be as far away from each other as possible. If they're too close to each other, then they will kind of hinder each other and hit each other. It's called steric hindrance. Steric hindrance. This is ethane. The next one is called propane. This is 3 carbons. Prop is the prefix for 3 carbons. All right, so here is like the simplest form. Again, this staggered kind of conformation is the most common conformation of these molecules. All right, remember we talked about a shorthand, which is kind of like sticks like that, where at this end I have a CH3, this end I have a CH3, and then in the middle I have a CH2. So that's kind of what it's being shown here, but with all the hydrogens. All right, just to kind of show you, because a lot of people get confused. These bonds right here are free to rotate. Okay, single bonds can rotate. So this group right here, this methyl group, is just spinning around and around and around that bond. Okay, well, these carbons are also spinning around and around in the bond. So this group would be spinning around this carbon. The hydrogens are spinning around too, but you can't tell. So at one moment in time, this CH3 group is on the right side, and then if it spins, this group now ends up down here, and if it spins up again, the methyl group ends up over there. So technically this molecule, so if you notice how I have the methyl group, so I have 1, 2, 3 here, 1, 2, 3, I still have it here, 1, 2, 3. Don't be fooled by the structure. This is still 3 carbons in a row. It's just I have it bent, okay, because this methyl group could be here, right? And I can have that hydrogen in the place of the CH3 here, okay? So here just means that the 3 carbons in a row, here is where it's just bent. Okay, so the bends in the carbon chain don't matter when it comes to identifying different compounds. This is still a 3 carbon chain. It does not have to be in a straight chain. Okay, in fact, another way to draw this, let me show you another way. CH3, CH2, CH3. Well, that's another way where this group now is up at that spot right there. Okay, so don't be fooled by the structure. It's still 3 carbons. Okay, butane, but, okay, is the prefix for 4 carbons. Okay, so butane is when you have 4 carbons in a straight chain. Okay, now this is the first molecule where I can actually draw a different molecule for 4 carbons. Rather than having this carbon on, so let me actually just write it with the carbons without the hydrogens. Okay, what if I were to take this carbon and now attach it to this carbon right there? So I would have a molecule that looks like that instead. Well, is this still 4 carbons? Yes, it's still 4 carbons. However, they're not 4 in a chain. I've got 3 in a chain, and then I have one other hanging off of the chain. Okay, we're going to learn about this when we name compounds, but this is my longest continuous chain of carbons. You kind of want to get used to hearing that term, longest continuous chain of carbons, meaning it's the carbons that are bonded right like onto each other. Then you have this group which is kind of hanging off. It's what's called an alkyl group or a branched chain or an alkyl group. Alkyl group. Okay. So this has a separate name and we call it isobutane because it's an isomer. All right. I don't remember if we talked about isomers yet, but isomers we will talk about in a different slide, but since I brought it up, let me define it. An isomer is the same, in particular, this is what's called a constitutional isomer. Same formula, but different structure. I believe we talked about this in the last chapter. Same formula, different structure. This molecule is C4H10. This molecule is C4H10, but they are different molecules. Okay, so these have 4 carbons in a row. This has 3 carbons and then 1 carbon branching off of it. Okay, and these are called isomers. So here they kind of give you. So they are isomers, and specifically they're called constitutional isomers. Okay, where they are 2 different compounds, but they have the same formula but different compounds. Another example, I believe this might have been the example I gave, is ethanol and dimethyl ether. These are 2 totally different compounds. This is what's called an alcohol functional group, and this is an ether functional group. 2 different functional groups. However, the formulas are the same. C2, hit that button, C2H6O. Okay, this is where the OH is. I have 2 carbons linked to each other and then the oxygen. This is a carbon, oxygen, carbon. They are same formula, different structure. These are also 2 different constitutional isomers. They aren't alkanes. They just kind of want to show you a different example. Okay, so why don't we stop right here? This is a good place to stop, and we will continue with this on the next video.